Hi, this is a quick ad hoc screencast on how to change the upper limit of FFT calculations for any particular purpose. The reason that they're limited to 32 in the user interface, and if we click this, the slider goes to 32. That's really just a graphical thing for the slider. But beneath that, there are a couple of things going on. And so if we look at the FFT spectrogram, and this is a beta build of 14C, so that's why it says beta build in the upper right. But the operation is the same in this case for 14B, and it assumes you have the research license unlocked. So I'm just going to click this label that says FFT spectrogram and go to the data tab, and I can edit this. Now these values are already calculated and stored. So here's the reason right here is that this is a setting that you can change. Now by default, it's 64 Hertz. Because we're displaying up to 20 here, 64 Hertz means it can calculate to the Nyquist limit, which is 32 Hertz, and that's what's stored with the record. Why do we use the native sampling rate? Well, if you're sampling at 1024 Hertz, why calculate and store everything up to 512 Hertz? It just bloats the results file. It makes those FFT results much larger because you're calculating and storing all the way up. And so what this really does is says, for this purpose, regardless of the native sampling rate, just calculate up to this point and store, so calculate based on a 64 Hertz sampling rate, which means you get up to 32 Hertz, and that's great. That covers most applications, right? But sometimes you want to go higher than that, and this is how you do it. And so all we have to do is increase the sampling rate. Now this is grayed out because it's already calculated. So we'll quickly run through the steps of how to give you greater headroom. Now those FFT values then can be used for spectrograms. It can be used for power, FFT power. So if you're doing 20 to 40 Hertz power, create a trend for that. It opens that up, and we'll set it to 128 so that you can go up to half the sampling rate. Step 1, clear the trends. Step 2, you can modify things right from trend preferences with the research package because you've got save and save as. I'm going to go ahead and do modify template mode, because I'm going to pick the default trend setup. You can use any one you want to start with. This opens up an editing window, and that's how you do it with the clinical version, because changes that you make in the first window would be for that particular recording, because there's cases where you want to make patient specific modifications to a trend layout, and it's saved with that patient's recording in their folder as a whatever the file name is .mmx. And then there are the other scenario where you want to make changes to your trend template for everything you're going to process. That's modify template mode. How do I know that I'm in the modify template mode? Is I only have a trend preferences. I no longer have a modify template. So let's modify the engine parameter. So you go to trend preferences, and again with the research package unlocked, I can get to the calculation engines tab. And if I look for the FFT engine, here it is, click edit. And there's my 64 Hertz, so let's double that. And this will say calculate everything up to 64 Hertz, because that's half of that. Now when I increase the sampling rate, you can see the epic duration dropped. So if we go to 64 again, not 65, good here, 64, 8 seconds, 128. And that's the inverse relationship between frequency resolution and time resolution, because if I then say, well, I want an epic duration of 256, I get back to an 8-second epic duration, but now my frequency resolution increases from 1 Hertz down to half a Hertz. I get better resolution. Let's say I want the same epic duration and the same frequency resolution. Well, you just change your windows per epic. So instead of 8, we'll go to 16 windows per epic, and we're right back where we started. We've got 8-second epics and 1-second frequency resolution. Again, these can be set based on whatever the needs. Now, as you increase the sampling rate, you're storing more FFT values. And so on a clinical day-to-day use, that just makes the results files larger. And after you do so many patients, that can begin to create some bulk. So if it's not used, this would be more for a research application where you're actually using those values. So of course you want to calculate them and store them. Same thing with epic duration. If that drops in half, or if the frequency resolution was twice this, it's just storing more values. It's not a problem. It just means that the files storing more values get larger. So if you're going to use them, great. But if they're not being used, It's just an efficiency, really. So we're going to stick with this. Long story short, we've increased our ceiling to 64 hertz, and we kept our epoch and frequency resolution the same. Click OK, save as, and I'm going to browse. I've already got a name set up for this, custom FFT range. It's going to overwrite that. So now this is trend settings version P14 custom FFT range. You can call them whatever you want. And so when I go back, it's like, wait a minute, I still see the old trend name up here in the title. That's the one I have loaded. Click open. I don't want to save changes to this. I want to open this custom FFT range. So now it says this up in the dialog title, trend settings version P14 custom, yada, yada, yada. So we go to FFT engines, edit, and those are the values. So what happens now? Well, now we can go ahead and change how these are calculated, or up to what range. Now again, if I click the range on either end of these for the y-axis, it still goes to 32 hertz. That's just the slider limit. So how do we change it to go 0 to 40? So I'll click the label here, FFT spectrogram, click the spectrum tab, and if I want to go to 40, just type in 40. And then I want to change the axes for this. So if I click here, I can go ahead and change this. And again, if I click here on the 0 to 20 and crank these up, they go to 32 hertz. Well, that's not high enough. So when I click this FFT spectrogram label, go to the axes, I can say, well, I want this to be something different, and I can put in 40 here. And you can see now that goes 0 to 40 hertz. Let's do it with the other one. FFT spectrogram, axes, 40. Okay. So let's see how that looks. Let's save our changes while we're at it. Click save, okay. Process. And we'll see now that we're calculating up to 40 hertz. How do I know? It's because it's rendering colors all the way up to the top. So speaking of rendering colors, square root scaling, it takes the square root of each amplitude value by frequency, right? And the reason for that is typically you'll have more amplitude, spam call, of course, more amplitude in the delta range than you will up in the beta and gamma ranges and so forth. So by taking the square root of each value, it allows us to render these in a way where you don't have to rescale it quite as often. It allows us to use the whole range of that without having to click this more frequently to fit things in that. But you can see this actually changes how these are plotted within the scale. But sometimes you don't want the square root values to be exported to CSV. So how do we address that? I'll go ahead and pause the processing. Let's go back into the parameters for this FFT spectrogram, and let's select microvolts for both of these. We'll go to this, spectrogram microvolts. So now these are being plotted in microvolts. You can see this has changed. It's not taking the square roots anymore, so we have more blooming in the delta range, and it's darker up at the top. So if we wanted to scale this to see what was happening in the beta range, of course we have to drop it down. We get even more blooming at the bottom, but you can see that it's calculating all the way up to 40 hertz. And if you're exporting the CSV values, the scaling doesn't really matter. So now we have a linear calculation of those values just using the raw microvolt values rather than taking the square root values of that. And there's that seizure. So that's how we do it. And then if we were to export the values for this, which I could do by highlighting these two, I could drop a range in if I wanted to, and then I could export that, or I could use the batch processing features to export those. But then those would be in microvolts instead of the square root of those values. That should cover it. Any questions, feel free to contact me. This is Michael Guest, VP Research and Clinical Applications for Persist, and I hope the rest of your day goes great. Thank you.